Okay. Good morning, Dr. Faizan and fellow friends. Today, our group 3 Adlv, will present the activity Jigsaw Group for sampling and sample preservation. Next, our problem statement is a chemical waste was dumped into a river, causing a water, soil, and air pollution. Various officers from different departments is involved to investigate the cases. We are going to plan the sampling and sample preservation in this case. Next.
So thank you, Ken Hao. So this is our role in our group. So Fatin is the environment officer. So me, Tan is the fire department hazmat. So Nurin is the department of chemistry. Eng is the department of fisheries, and Fu is a local resident. So basically there are three samples that we're going to take. The first one is water sample. So for water sample, we can we can take the gross sample for different locations of the river. So if the river is not deep, we can just directly take the sample in the center of the river flow. So before we take the sample, we need to wash the container that we're going to use 3 times by using the river water. Then we fill out the water sample, we close it tightly, then we label it. So when we're taking the water sample, right, we need to be careful that we don't touch or we do not kacau the bottom of the river, because if we touch the bottom of the river, the soil or all the impurities from the bottom of the river will goes up. Then we will the water sample that we take will become will have impurities inside. So if the river is very deep, we can use the apparatus, what we call is Vendon water sampler. So basically, Vendon water sampler is used to collect the sample in a very deep location. So the second sample that we're going to take is soil sample. We can take it by using grind sampling or zone sampling. So there are two apparatus that we can use to collect the soil sample. The first one is the shovel. The second one is the soil sampling probe. So basically, the soil sampling probe is a apparatus that easy to use. We just need to take the probe, then we chuchuk it into the soil, then we just pull out, then we can take the we can get the soil sample. But for shovel, right, we need to before we take the soil sample, we need to clean the soil surface first, remove all the impurities like grass or rubbish. Then we make a small hole and we mix the soil. Then we can take certain amount of the soil, then we collect into a plastic container. After that, we repeat the step uh, at different location of the riverside. So depends on the situation. Then once we get all the sample from different location, then we can mix it and send it to analysis. So the third sample that we're going to take is a fish sample. For standard method, we prefer standard addition method rather than a linear calibration method, is because most of our sample are get from the river or riverside. So basically in Malaysia, the river are very dirty and it have a lot of impurities and also metric inside. So the reason why we prefer standard addition method is because standard addition method take the matrix effect into consideration. Because the matrix will interfere and affect the analyte signal during the analysis process. So that's all from me. Thank you.
So as a local resident, the things that we can do is to observe the surrounding that happen to us. For example, residents fall sick, foul smell, color of river change, crops are dying, animal poisoning, and water destruction. To conclude, where are the places that has been contaminated? After we observe the abnormal phenomenon, then we can report the situation to the Department of Environment. Before the authorities start to take actions, we can do some precautions, for instance, wear masks, drink water from bottles, and avoid outdoor activities.
Next, as an environmental officer, I would like explain how to preserve the samples. For water, sodium thiosulfate, a dechlorinating chemical used to prevent any chlorine reactions, is a common preservative. Methyl isobutyric or as known as MIBK, also can be used to remove the organic impurities and to minimize the interference. For solid should be stored air dry. Air drying can be done at room temperature, for which you separate the soil as much as possible to have a large surface. Better you use an oven with recirculating air. Temperature should not exceed 35 degrees Celsius. If samples cannot be taken to the lab within 24 hours after collection, they should be dried, refrigerated, or frozen. Dry soil samples by spreading them out to air dry at room temperature for 2 to 3 days, depending on air circulating and humidity. For fish, we have to put at -20 degrees Celsius prior to toxin analysis. Next. So how to store the samples? For water, keep the sample as cool as possible without freezing to reduce the possibility of volatilization of biodegradation between sampling and analysis. Before shipping, pack samples in crushed or cube ice or a commercial ice replacement. Dry ice should be avoided since it can freeze the samples and cause the containers to crack. The pH of the samples may also be affected by the use of dry ice. During collection, keep composite samples cool with ice or a refrigeration system set to 6 degrees Celsius. Analyze the sample as soon as they arrive at the laboratory. If quick analysis is not practicable, most samples should be stored at 2 to 4 degrees Celsius. And easier for soil and fish because for soil, just place sample in a plastic bag, and for fish, store in a freezer.
Okay, on how to prepare water sample. First, 10 ml of methyl isobutyric is mixed with 50 ml of river water in 250 ml conical flask. The mixture is heated until half of its volume and undergoes filtration after cooling down. Then the mixture is ready for analysis. Right. For soil sample preparation, 1 gram amount of each sample was weighed and the weight recorded before digestion using nitric acid. 2 ml volume of concentrated nitric acid reagent was added to each sample and left to stand for 10 minutes to allow any reaction gases to escape. Next, 6 ml of concentrated hydrochloric acid was added and the sample were left for another 10 minutes. The sample were then heated in a microwave digestion system. The sample must be heated to 175 degrees Celsius within 10 minutes and then continue to remain between 170 and 180 degrees Celsius for another 10 minutes. After the microwave digestion program was complete, the sample container were left in the microwave digestion system for 5 minutes to cool down. The sample digest were quantitatively transferred to 100 ml volumetric flask made up to volume with ultra pure deionized water. The samples were left overnight to settle out any suspended solids.
So next is fish sample preparation. We'll prepare it to the solution for using for LCMS analysis. So for first stage is an extract equilibrium of 5 grams of fluid was dissolved in 2 ml of ethyl acetate, which we are just using the fish. Then the solution was passed through a Foricil cartridge, which is this one, and eluted with 2 ml of the same solvent and then dried under nitrogen at 40 degrees Celsius. The residue was dissolved in 3 ml of acetyl nitrate, applied to a PSA cartilage and washed with 3 ml of the same solution, acetyl nitrate, and the target toxin was eluted with 3 ml of ethyl acetate. The eluate was dried and dissolved in 200 microliter of ethyl acetate for LC-MS analysis.
How you should analyze the sample. For water, we use atomic absorption spectroscopy. For soil, inductively coupled plasma optical emission spectroscopy.
And for fish, we are using liquid chromatography mass spectrometer (LCMS). So this is our reference from journal, and this is our meeting for each department. Yeah, thank you everyone, and have a nice day.